Yeah, let's dive right in. So this is definitely quite a bit of a loaded title, but hopefully it's going to be somewhat entertaining for the audience here. So maybe to just give a bit of background of what I'm sort of trying to convey in the next 25 minutes or so. So if we generally look at, just as a bit of context, where cloud dev is today, especially in the context in the age of AI, a bit of background of sort of where cloud development has been coming from, like from the early days of early cloud adoption in the 2000s, sort of into the more mainstream adoption in the 2010s and sort of into the 2020s and beyond, right? So initially there was definitely like this big realization that cloud is this hugely scalable production infrastructure, allows us to do things like DevOps, automating all the things, and you have these huge economies of scale of just building these amazing production applications. Midway through sort of the mainstream adoption, the realization came that actually cloud is also a pretty expensive platform, right? So once you deployed your services and spun up maybe some VMs and like different components and things that just have this tendency to grow and grow over time, and things just become expensive. So there was this optimization and FinOps wave that was kind of coming midway through the mainstream adoption. And then I think what we're seeing in the last couple of years or so is definitely more focus on the developer experience for humans, right? So this is kind of the third wave here that I'm showing in this chart, where really the developer experience was often a bit of an afterthought when cloud first came about, but there's a lot more focus also from the cloud providers more recently around, okay, what is a developer, and in this case a human, how do they actually interact with the cloud, and what's the developer experience? And of course, more recently, as AI is gaining traction, is finding more adoption, there's more and more specialized tools, and also the AI tooling converges in the cloud space, right? So thinking about things like virtual cloud GPUs, vector databases, RAG pipelines for different kind of retrieval and AI workflows, MCP servers, and many other things. So cloud providers are definitely innovating a lot in the AI space and kind of marrying the two concepts together in a sense, and making the cloud developer experience the best possible experience. So I think it's fair to say that LocalStack had a pretty big impact here in the cloud DevX realm, right? So we are very fortunate to be working with a huge global community of users who are working with LocalStack on a daily basis and really are contributing to our efforts here of providing a local-first cloud developer experience. So I think it's fair to say that we have had and continue to have a fairly significant impact here. But we do also see a huge opportunity in sort of these more recent developments, right? With cloud workloads being optimized for AI. And I think our special solution with the local emulator, local execution, gives us a huge boost and benefit as opposed to like running things in the real cloud environment. And we'll dive a bit more into that. So generally speaking, we're seeing with increasing adoption of AI, there's more and more patterns and use cases to support AI-powered workloads with LocalStack. So that's something that's certainly coming up more and more in our customer and user base. So if we sort of zoom out a little bit and just look at AI engineering more broadly with LocalStack, how LocalStack as a solution can support you in your AI engineering workloads, there's essentially three main pillars that we see how LocalStack really unlocks new approaches for AI application development. The first one is AI cloud service emulators, right? So we, a couple of releases ago, we had first versions of Bedrock, for example, a local version of the Bedrock service that allows you to run LLM models locally in your local machine in LocalStack to enable end-to-end pipelines that involve LLM interactions. We also have support for SageMaker, where you can run AI model training and inference, and add that again as part of your development and testing flow of your local cloud development testing. In the future, we also, some of you may know that we launched a Snowflake product recently, and this is not implemented yet, but we're also planning to support Cortex AI, which is the main AI functionality provided in the Snowflake platform. So that's really, using AI services, the local emulators as a representation, a local representation for the production workloads, that just allowing you to test efficiently and quickly on your local machine. The second pillar is MLOps, right? So anything around testing of AI and ML data pipelines. Essentially, every AI model can only be as good as the underlying data, right? So having this well-curated data is critical for any AI or ML application workloads. And LocalStack facilitates dev and test for data pipelines, ETL jobs, and other data engineering activities. So we have features like, or services like Airflow, again, Snowflake, Redshift, Glue, Athena, and a couple of others that are really targeted towards the data space. And then the third area that we see is just AI agents and providing a secure execution sandbox for AI coding and vibe coding, which is something that's coming up more and more, where generally these new AI coding environments raise a lot of concerns around security, costs, and can I actually let my AI loose against the real production environment? So LocalStack really provides a solution here for a fully isolated test sandbox that's entirely risk-free for your AI-driven development. So there is some prior work on the first two pillars, and in this particular demo, I want to focus mostly on the third pillar. And towards the end of the presentation, I also have some pointers to some of the other sort of existing blog posts and videos that you can check out for the other two pillars. So focus is on AI agents and vibe coding, and that's an interesting topic. Of course, it's gaining more and more traction. It's a fun activity, but we want to just give it a bit of a reality check with the demo use case if it's actually feasible and works with LocalStack. So this is a sample application we'd like to kind of develop now as part of this demo here. It basically consists of a couple of different components. So let's assume we have some client application like a terminal that uploads a file to an S3 bucket. And the S3 bucket should trigger some notifications whenever a new file is uploaded into a Lambda function. A Lambda function gets invoked and then actually calls, does some processing and then calls a separate API that sits in an ECS task. Again, all running locally on your local machine. And then finally, this ECS task is going to add a record to a table that we're going to store in a Snowflake database. So fairly, simple end-to-end flow after all, but it definitely consists of a couple of different components that we're now going to try and stitch together with an AI agent. We could of course argue, okay, do we need this Lambda function here in between? Couldn't we write directly to the ECS task? So please don't, take it with a grain of salt in terms of the actual application scenario here. It's more for illustration purposes, but I think it showcases nicely a somewhat representative serverless app, containerized app running on AWS plus Snowflake. All right, so that basically leads us to the live demo. Just a quick disclaimer here, we're definitely at the mercy of AI, right? So there's a non-zero chance that the demo will catastrophically fail, right? But may the AI demo gods be with us, and we'll see how it works. At least we can always blame it on the AI and not LocalStack. All right, so what I'm going to do is I'll head over to, so we'll just keep this architecture in mind, and I'll head over to my IDE. In this case, I'm using Cursor. You could, of course, use any other coding IDE or something like, Windsurf that has a native AI integration, or Cloud Code, things like IntelliJ, Juni integration. So, basically any kind of AI coding agent here. And it's pretty bare bones setup. So it's a blank workspace. Effectively, we only have an mcp.json. So this defines MCP servers that are running in my workspace here. I've defined two different MCP servers, one from the official sort of AWS labs, which is sort of the official AWS supported one. And there's also a community contributed one, which I've had quite some success with. It's a Docker image that's available on this particular Docker Hub registry here. So that's just our mcp.json. So this will allow the AI agent to interact with LocalStack locally. So it's going to translate AWS commands into basically local AWS commands running against the emulator. In the cursor settings, we can see that this one is enabled here. It has these two tools, which is the CLI help and the CLI pipeline. So cursor will basically just make use of these MCP servers whenever it generates some commands to generate code. All right, and then the other thing I have running here in my terminal is a LocalStack instance, right? If I just do a quick Docker PS, we can see that LocalStack is running. I'm actually running the Snowflake flavor, which includes both AWS and Snowflake, so we can run the full end-to-end scenario on our local machine. All right, so let's see how it goes. I think we probably also need to time box it, so I think I have probably like 10 minutes from here on. Let's see how far we get with some prompts and generating some code. So The first thing we want to ask Cursor here is to say, create an AWS Lambda function connected to an S3 bucket notification defined via Terraform and deployed using the T of local apply commands, right? So T of local, as some of you may know, is the our drop-in replacement for the Terraform CLI, and it basically just points all the deployment against LocalStack directly. So we can see here now it's actually starting to come up with, analyze this request, and it's starting to generate some plan, and already the first files are being generated here. So as this is being created, we can observe what's going on. So we can follow the reasoning process, right? So it's now created a directory, the Lambda and the Terraform directory. It actually already created a Lambda function. So let's take a quick look at that. Just going to accept it here. So that just received the event, prints a status message. So that all looks good so far. It now goes ahead and initializes the provider plugin for Terraform. So seems like it's already done the TF local init, and now the TF local applies is running. You can see here in the log output, I'm also tailing the logs from the LocalStack container here. So you can see as this thing is running, it actually also outputs some commands here. All right. The following has been completed. So it seems like it's already done with this first step. So let's take a quick check if everything works. So if I have this in my terminal history here, if I just copy some file from my local directory here, let's just copy the prompts txt to the, I think it's called, what is the bucket called? Let me check it real quick. It's local s3 ls. So the bucket is called demo bucket LocalStack. Okay, so I'm just going to copy some file there, and we say, could have of course also done this via Cursor directly, but I just did this manually. So I uploaded the file here, and we can see in the background LocalStack is actually triggering the Lambda function, and we can already see it's printing the output here. So nice, great job. Already the first step is done. So we have a Lambda function connected to an S3 bucket notification. And one thing you'll notice, I'm sort of developing the application iteratively here. We could have also given the AI the entire application, so it just built the whole thing. But I guess you might have had mixed experiences or mixed sort of success with just building the whole thing. I think it is my experience. It's sometimes better to build things step by step, one thing at a time, and then kind of letting it make this incremental progress. But I guess there's different approaches to how to achieve the same thing. Okay, second prompt is create a local Python script to connect to a Snowflake database at this host here. I'm just going to use the local host. Create a table called uploads with columns for file name, size, timestamp, and insert a few sample records. Okay, so we're just gonna add this here to the prompt and gonna ask it to do its thing. So what's happening now? I'm also giving it a hint that for the Snowflake connection, we should install the dependency Snowflake connect to Python if that's not installed yet. So I would expect it to maybe create some requirements txt file. Yep, there it is already. So it created the requirements txt. We can accept the changes here. And it's basically just going ahead and installing and generating this simple script here. So let's take a look at what it's generated here. I'm just going through and accepting the files. So this was the file that's just generated for the Snowflake connection. So it starts with a connector that just says account and host. So that actually, I'm going to make a small modification here. I think the account should better be test and not the host name. So that is a bit of a hiccup here. Database, this should be fine. Schema. Okay, so the rest should hopefully be fine. So that looks good so far. And what it's now asking me to say, you can now run. Okay, so I can run the script now to execute the script. Let me go into my terminal. I would have expected this to be done directly by the agent, but it's asking me to do it directly. So there you go. So there we have our first issue. So database does not exist. So let's just work with the prompts. Actually, let's let the AI run the command directly, because then it should basically figure it out that there's something wrong in the script. So it's usually, at least my experience so far, quite nice itself. We're linked up to the script. Yes, please update. It's usually quite smart. It's sort of self-correcting any errors. It's a bit of an iterative process usually, but once it gets the hang of it, so we can just accept these changes, accept. So it's now adding a create database if not exists. There's another one. Just going to say yes to most of these questions here. I'm going to change run the script. Nothing compatible with backend doesn't recognize a string. Interesting. That's definitely already more issues than I've seen in my first trial run. Let's see how that goes. The other thing does not exist. Okay, so there's some interesting stuff going on here right now. Okay, so let me do this is obviously like a nice demo effect, but we'll just do a quick restart of the whole thing and then see how that goes. And that is, of course, the demo effect that you can always expect, right? It's indeterministic. The AI, I just restarted the LocalStack container, restart deployment from scratch. Let's see what that gives us. Yeah, so this is definitely like the indeterministic nature of things, right? So it's definitely a bit of a back and forth. Again, I think the same thing would certainly also happen against the real cloud environment. It's not necessarily a manifestation of LocalStack, but I think it shows some of the strengths that it has, but also the weaknesses, right? I think it's always good to take it with a grain of salt and see what actually works well and what does not work that well. Just gonna undo that change, reject this one. All right, apply complete. Yes, proceed. Let's see what's coming up next. It's asking me to do this change here. Let's see. Yeah, I see we definitely need to time box this. Maybe give it another 5 minutes or so, and then we can see how far we get. Okay, success. Okay, it says success now, so that sounds good in general. So let's do a quick verification here. So I have a dbeaver instance running here, which is basically a database connectivity tool, and I should be able to quickly refresh here and then connect to our LocalStack instance. Let me just quickly go here. So where's my script? So I think the table should be called uploads. Does not exist. Reminder right. Use database. This is fun. This is probably the most open-ended demo I've done in quite some time. You never really know if it works. Okay, cool. So these have been inserted. So apparently our uploads table exists. It has some records in it. So that's awesome. Love it. Great. So just accept these changes here. All right. So it seems like the second step has worked so far. So we now have a Python script that connects to the Snowflake database on our local machine, creates a table and inserts some data into it. Awesome. All right. So as a next step, what we want to do, if you look again at our script here, we actually want to wrap the logic into an ECS task, right? So the whole sort of Snowflake connection should not run on a local machine, but we actually want to wrap this in a task. So what we'll try is we're going to run this prompt here. So wrap the Snowflake test script into a Flask API server endpoint, bundle the code into a Docker image, and just building the image. I've given it a small hint here because last time it tried to access a certain function, last inserted ID, which currently is not supported in the emulator yet. So that's a small hint that I gave it here. And then we wanted to deploy the ECS service with the image to LocalStack, making the Flask API accessible via network port. And I'm just going to ask the agent here to go ahead with this. So what we would now expect to see is that this Snowflake test script gets wrapped into a Flask API app, which you can already see being created here. I'm just going to accept this. So it's creating again a bunch of files. Next thing is going to be some Docker file. Yep, exactly. Which just basically bundles up the whole application. Just going to blindly allow it to do things on my machine. This is again, we're actually executing kind of in YOLO mode here. I've basically given it access to my entire local system. So that's, of course, always a bit of a risk factor, but it seems to be only doing harmless things like building Docker images and so on. So that's fair. And so while it's doing its work here, so I think it's now building the image, exporting the layers. So that's going to be available in a couple of seconds. And then it comes up with a new plan to deploy this ECS task, right? So you may have noticed, like, I've given even another small hint here, which is a bit of a LocalStack specific thing, but I mentioned there's no need to create an ECR registry. This is not required in LocalStack. The Docker image can be referenced directly in the ECS task definition. So this is a bit of a shortcut, so we don't need to create an ECR registry, which is also possible in LocalStack, but it's something we don't need to do here. All right, so it's telling me that the Flask API is now up and running, which I hope is the case. Let me know if you need to verify. Yes, please verify the service. Yes, please verify whether it's up and running. Okay. I always love how it's saying, yeah, working correctly. That's nice. Let's do another check here in DBeaver, how many records we now have in the database. It's still 3, which is interesting. I would have expected maybe more. But maybe that is already sort of just doing it idempotently and just adding the same records, basically, if they don't exist yet. Okay, so that seems to be working. So we now have an ECS task. Let me actually just take a quick look at the ECS task implementation, what it actually does. So the Flask app is here. So it has this route with init uploads. That's basically the only thing that it has available at this point. Okay, cool. So now we have a very basic ECS task. And now sort of this last step is a bit of a bonus. I'm not sure if we want to get to really the end of it, but the goal would now be to say we want to extend this Flask app now to say create another endpoint that allows us to insert a single record into the uploads Snowflake table. We then want to rebuild the image, redeploy the ECS task, and also update the Lambda function that it calls the ECS task via HTTP. So there's a bit of more changes involved, and I'm curious to see how whether it's going to be able to actually get that done. So we're going to give it this final challenge here, this final prompt. Again, I've given a few small hints here that are a bit LocalStack specific. For example, the HTTP request from the Lambda to ECS, it can use a special hostname here. Of course, you could also just go via a regular ALB, like an application load balancer ingress. I've basically given it like a bit of a shortcut here to just make a direct connection through the Docker network directly. So let's see if that actually goes ahead and works. We're still well on time, so maybe just a couple more minutes. So it's doing its thing. Curious to see how the Flask app is now looking. So it had this new route endpoint add uploads. So you can basically post the JSON payload, and then it's going to insert it into the database. So that so far at least is looking good. The Lambda has also been extended with a bunch of libraries here. The Lambda function itself has been extended. Curious to see if 8080 is actually the right port that we need to connect to. So I think there might be some hiccups, but it's at least getting pretty close. So curious to see like the final integration if we get it working all end to end. But I mean, I think what we can see here is already quite amazing. Actually, if you think that we started from a blank canvas, basically, we of course didn't need any AWS credentials, no Snowflake credentials. Everything is running on my local machine, literally risk-free. And it's telling me that it's done. So now I'm really curious to see if it actually worked. So the ultimate test, let's do another copy. So I'm just going to copy this main kf file again to the example bucket. Sorry, it is the wrong. So S3. So what's the bucket name again? Demo bucket, and then we're gonna copy some local file. It doesn't really matter what we're uploading, it can be any file. Let's just upload the Docker file. Okay, so that's running. And if we look at the LocalStack logs now here in the separate terminal, it has triggered the Lambda function. Okay, so then it said error calling the Flask API. module request has an attribute posts. Curious what that actually is about. So just give it 1 or 2 more minutes. So request.post. Surprised. I would have expected that to work. Okay. Let's just see if it comes up with a quick solution. Otherwise, we can also call it a day from here. Seeing error in the Lambda. We could, of course, also scrape the logs from the Lambda directly. This would be like kind of the ultimate feedback loop. So let's see if now it's trying to do something in my file system, which, it's trying to look into the Lambda function. Okay, I see. So it might have actually included the wrong request library or something like that. Anyway, I think we can stop it from here. I think from here we would have to do some manual adjustments. But I hope it was maybe giving a bit of an insight into what is technically possible with starting from a blank slate, just running a bunch of prompts and then generating some code that actually delivers a proper application. And again, we only had 15 minutes or so. It was a stretch code, anyways. So I'm gonna stop at this point and just wrap up with a few, summary and concluding notes. So, what are these benefits now of using these local AI feedback loops, right? So let's assume we wanted to develop the same application against the real cloud, basically what we just did. And I think there's a couple of things to note here, right? So first of all, the feedback loops in terms of the speed, I think it's an order of magnitude faster, right? It's pretty clear. Pushing an image to an ECR registry, deploying the ECS task in AWS, this can take at least several minutes each time you make a change, which is painfully slow, of course, especially with many iterations of changes. So that, of course, brings a big benefit for the local execution. Security is another factor, right? So the AI-generated code might have exposed some security holes, some open network ports, loose IAM permissions, and so on. We definitely don't want to let AI loose against some kind of critical infrastructure that's security vulnerable. And then the third part is, of course, costs, right? So cloud feedback loops are expensive, right? So even though in this case it was maybe just Lambdas and a few containers, but the AI may spin up various resources in the process, and how can we make sure that it actually properly cleaned up after itself? So I think there's a lot of cases we made for this local execution of a local, being able to drive this more and more efficiently. So to sum up, I think we have a pretty powerful combination for enabling these next-gen AI application development scenarios, right? It's AI coding agents, things like Cursor, Windsurf, whatever they're called, plus MCP servers, which are really this standard protocol for accessing different systems, and also gives us easy access to the LocalStack emulator. And then LocalStack emulator kind of adds to this trio, which really brings us in combination these quick feedback cycles, zero risks, and definitely reduced costs in everything we're doing in our crazy experimental AI dev loops here. So that's pretty much what I wanted to share. Hope it was an interesting experiment. I think it was 60 to 70% successful, I would say. I've had previous runs which were definitely looked better, but I think it was still fun. I hope you also enjoyed it. Curious to get your feedback and experience reports also maybe in the chat on YouTube or on other channels, or just share the feedback what experience you've been having with agentic AI and using it for vibe coding. There's a couple more pointers here. The LocalStack docs, I would like to point out the SageMaker and Bedrock. Give it a try if you haven't already. We're actively looking for feedback in terms of how we can also enhance and evolve these services. Please give it a try. There's also some nice meetup talk that I've linked here in the notes, as well as a blog post around developing cloud AI-powered apps with LocalStack and Waldemar. And there's also the AWS MCP service, which might be interesting for you all. So stay tuned. I think there's a very exciting times ahead. We're going to have more updates in the upcoming months, and stay tuned for more. And hope there's maybe some questions from the audience.